Take a look at this herd. Thousands of dairy cows are grazing in a perfectly defined block of pasture. But as you look toward the edge of the group, there are no wooden posts, no gates, and no wires. It creates a physical contradiction. These animals stop at an invisible threshold, refusing to cross into the open field, as if hitting a solid wall. This is the work of Halter, a New Zealand agritech company. They've developed a system that replaces traditional fences with a combination of high-precision GPS and artificial intelligence. The innovation here isn't a stronger physical barrier. It's the use of technology to move the fence from the field into the animal's own internal navigation. For thousands of years, controlling the movement of livestock required massive amounts of physical infrastructure. If you wanted to move a herd, you had to build a cage of wood and steel to hold them. Managing a large farm meant constant manual labor, physically tearing down and rebuilding these barriers every time the animals needed fresh grass. The Halter Smart Collar was designed to remove that physical labor from the equation. It's a solar-powered device that sits around the cow's neck, acting as a portable digital gate. Physical containment creates a hard ceiling on how large a farm can grow and how quickly it can adapt. Moving that infrastructure into a digital layer removes the final material friction from large-scale land management. The fence starts on a screen. A farmer draws a shape over a map and hits Set. The boundary is uploaded. Each collar uses GPS to track exact coordinates, while AI processes real-time movement data, predicting the cow's path toward the line. The pasture is now divided by coordinates and predictive algorithms. The boundary is invisible to the eye, but for the animal, it is becoming a fixed reality. Curious, but how does a cow learn to respect a line it cannot see? As the cow approaches the limit, the collar begins an automated escalation. First, it emits a specific audio warning, a sound the cow learns to identify. If the cow continues forward, the collar delivers a tactile vibration. It's a physical nudge that serves as a second, more urgent warning. If the boundary is actually breached, the collar delivers a mild electronic pulse. This three-step process is a standard operant conditioning loop. By linking sound and vibration to a physical consequence, the hardware begins to program the animal's choices. This isn't a permanent state of punishment. Within 5 to 10 days, the cow's brain adapts. It associates the harmless audio cue with the boundary, choosing to turn back on its own long before it reaches the shock zone. Following this short adaptation period, the herd remains contained 99% of the time without the collar ever needing to deliver an electronic correction. The AI has successfully used a digital illusion to rewire the biological behavior of the entire herd. This technology gives farmers absolute fluid control over the landscape. They can move thousands of animals or section off specific areas of land with a few clicks from a remote office. It replaces the slow physical constraints of traditional farming with a system that is as agile as a piece of software. It is a future where maximum physical control is achieved with a zero-footprint digital infrastructure. The success of this conditioning on a farm raises a broader question about how these same feedback loops interact with us. The Halter system proves that when digital signals are tied to precise sensory feedback, they can reliably govern biological movement. Humans already operate within a similar network of sensory cues. We respond to the haptic buzz, the chime of an alert, with the same instinctive speed as a cow hearing a warning. If AI can draw invisible boundaries that animals learn to unquestioningly obey, we have to wonder what boundaries are currently being drawn for us.